continuing with our Chapter 3 review exercises. 37 through 40 says for the following graphs we want to find the intercepts, the vertical and horizontal asymptotes, and then use them to sketch a graph. Let's examine number 40 here. Alright, so we have f of x is equal to x plus 2 over x squared minus 9. It's a rational function. It's a fraction. Specifically, we have the variable x, the input variable, occurs in the denominator. So one thing we're going to do right off the bat is factor the denominator. That's a difference of 2 squares, x plus 3, x minus 3. Where the denominator equals 0 is going to be important to us. So we're going to set the denominator equal to 0. X plus 3 times x minus 3, setting that equal to 0. And if we do, again, we'll have x plus 3 is 0 or x minus 3 is 0. And clearly this will be x is equal to negative 3. And this will be x is equal to positive 3. These are excluded values. They won't be in our domain. So the domain would be all reals except that. The domain are x is not equal to 3 and negative 3. And they're going to be vertical asymptotes. The only time that zeros in the denominator won't be vertical asymptotes is if we had a like factor in the numerator. If this were an x plus 3, then that would cancel out that, eliminating this minus 3 as a vertical asymptote. But in this case, we will have vertical asymptotes at both those values. Vertical asymptotes will occur at that vertical line at x equal negative 3 and a vertical line at x equal 3. Okay, the horizontal asymptotes, there were 3 conditions. Review what those conditions are, but basically we're looking at comparing the numerator to the denominator. When the denominator is bigger, when the degree of the denominator is larger than the degree of numerator, the bottom is outgrowing the top. So we're going to tend to the x-axis. That is the line y equals 0. Since degree of denominator greater than degree of numerator, the horizontal asymptote is the x-axis, which is the line y equals 0. All right, now to find the intercepts. Find x and y ints. Okay. Remember the x-intercept, also called a 0, is some x value that maps to a 0 for y. The y-intercept is the y value when x is 0. So in both of these cases, we're going to substitute 0 in some place and then solve for the other one. All right. Let's start with our function again. X plus 2 over x squared minus 9. So we have f of x is equal to x plus 2 over x plus 3, x minus 3. All right. I'm going to start by finding the y-intercept. Super easy. The y-int. Let's let x be 0. Substituting a 0 every place we see x. So f of 0 is equal to 0 plus 2. 0 plus 3 in the denominator, and 0 here would be 0 minus 3. That is 2 in the top, that's 3, and negative 3 in the bottom. 3 times negative 3 is a negative 9. So that's a negative 2/9. Typically when we express a negation, we express it with a numerator. F of 0 is equal to negative 2/9 is the same as the point 0 comma negative 2/9. We would say the y-intercept, we simply say y is equal to negative 2/9. That's the y-intercept. For the x-intercept, we're going to substitute 0 in place of y. Now we're letting this right-hand side, that whole object, equal to 0 over x plus 3, x minus 3. Well, if a fraction is equal to 0, we mean that the top is equal to 0. So I can simply set x plus 2 equals 0. And clearly that's going to be x is negative 2. All right, that is our x-intercept is x equal negative 2. And we could use that to sketch the graph. So we know we have vertical asymptotes at 3 and negative 3. Vertical asymptote at x equal negative 3 and 1 at x equals positive 3. We're going to have a horizontal asymptote at y equals 0. Now remember, our graph can cross over the horizontal asymptote in between, but it'll approach it as we go to the infinities. So this graph is going to, you might say, have 3 parts. Something to the left over here, something between our vertical asymptotes, and something to the right. Well, let's plot our intercepts. We have a y-intercept at negative 2/9. That's slightly less than 0. We have our x-intercept at negative 2. That would be right here. And now you just want to consider what the behavior is going to be like as you get close to these intercepts. So imagine putting in numbers very, very close to x equal 3 below it. So if I'm very, very close to x equal 3, this would be like 6. And this is getting very close to 0 but negative. All right, so this denominator is going to be something negative. This numerator is going to be something positive. So we have some very small negative going into some positive that's going to be very close to, say, 5. So it's going to produce very large negative numbers. And you can kind of see that already. It's going down in this direction. So you're going to get this kind of behavior over here, and over to this side it's going to look like this. It's going to have this S-curve type feature in the middle. Consider what happens when we put very large values of n for x, like a billion. So a billion plus 2 is a billion and 2. A billion plus 3 is a billion and 3, and this is almost another billion. And so we got a couple billions multiplied together divided by just 1 billion. This thing is going to be very close to 0 as we get large. And this is what the behavior is going to look like in this direction. It's going to flatten out. As we get close to x equal 3 on the positive side, getting very close to x equal 3 but positive. So this is going to be something like 6. This will be something very close to 0 but positive. So you're going to get a positive divided by a positive. That's why it's moving up without bound here. On the left-hand side here, again, as we get very, very large negatives, it's going to tend towards 0. Which side, though, is the question. Well, imagine some very big negative number. You're going to have a negative times a negative. That's a positive. And here you would have a negative number. So a negative divided by a positive is negative. We're going to be on the under the below side here, and our behavior this way will look like this. Imagine taking a number very close to negative 3. All right. So a number very close to negative 3 plus 3, but slightly more negative than negative 3. This part is going to yield a tiny negative number. This part here would yield a negative number. So we have a negative times a negative. That's going to be a positive. This part would be negative. A positive into a negative would be negative. That's why we're tending in the negative direction. So when you're considering, you know what it's going to look like at the ends. It's just a matter, is it going to be heading in the positive or negative direction? Just examine values very close to the asymptotes. I'm not going to ask you any questions about slant asymptote. You can let that go. All right, 43 through 48 is dealing with inverse functions. This is a great situation because this will also help you review for 1.7 at the same time. So for the following exercises, find the inverse function with a given domain. Simply exchange your x and your y and solve for the other variable. Let's look at number 48. This would be one very, very similar to one we had from quiz 1. This would be practically directly out of 1.7. Okay, so we have f of x is equal to x minus 3, 2x plus 1. All right, so changing f of x to y. And now exchanging the y and the x. The inverse is the reverse mapping, so we're just going to simply switch the x's and the y's. Y will become x, and x will become y. Now we're going to solve for y. When the variable you're solving for is in the denominator, simply multiply by that denominator on both sides, multiplying by 2y plus 1 on the left and the right. This cancels on the right-hand side, leaving y minus 3. On the left-hand side, distributing the x, we have 2xy. X times 1 will be x. We're going to collect our y terms on one side, our x terms on the other, so subtracting y on both sides and subtracting x on both sides. The y's cancel to leave negative 3 minus x. The x's cancel to leave 2x, y minus y. Note that when we move from one side to the other with respect to the equal sign, it's a positive y on the right-hand side, it's a minus y on the left. Here we had a plus x on the right, it's a minus x on the left. Now I'm going to factor y out of the right-hand side. Y times 2x would be 2xy, y times 1 would be y. Solving for y, I'll divide by this quantity in parentheses. So we have y is equal to negative 3 minus x over 2x minus 1. And we call this the inverse function. We use this notation, f inverse of x. Looks like f to the negative 1 power. This function would undo the original function. These inverse variation, the variation problems here, I'm going to make a separate video that deals just with 3.8 because we didn't discuss that in class. That concludes this video.